Hi everyone. We are going to present our project, and this project was about age estimation based on images of tooth cementums. So this project was in cooperation with the University of Freiburg, and we tried to do this with computer-based approaches.
So first up, my name is Thomas. My background is in history and European studies, and I spent 5 years working as a journalist and as a data specialist in Singapore, moving to Switzerland to actually join this bootcamp and get into data science.
Yeah, and I'm Tomek Sizcek. I have a PhD in political science, and after the PhD, I did a postdoc at the University of Zurich, also in political science.
So often a question is how old is a body? And this is a question which is often asked in anthropology, archaeology, forensics. And because you can't ask them directly, you have to find out for yourself. Most commonly, dental records is used because teeth last for a very long time. And more recent development has been a process called Tooth Cementum Annulation, where you slice part of a tooth and you get this sample and you put it under a microscope and you can count the cementum bands, as you can see here. They're not very clear to see, but if you have the domain knowledge, you know what you're looking for.
Next slide. Next slide. Yeah. So the other motivation was that if you do it by hand, it's very time consuming. It's a very labor intensive work because you usually require at least 2 coders to get reliable results, and they are nevertheless not very accurate. So our goal was basically to outperform a human coding-based measurement of age based on tooth cementums. The first attempts were not very promising. So we run different models like ResNet, we did Exception, EfficientNet, B7, and all the different popular approaches in image processing. Then in the second attempt, we were more successful. What we did is we rearranged the images manually, and then we sliced them into 4 different, vertically into 4 different images, and then we fed the 4 images simultaneously into the model. But you can see the results on the right side. However, yeah, it's the accuracy and the accuracy was more or less the same that you would reach with human-based approaches, but we still one of the main problems was the limitation of the images. So what we did next is we first performed a GradCam analysis, and GradCam allows us to understand what the model looks at when it's predicting the age. And what the region of attention is. And what you can see on the right side is that whenever an image was wrongly predicted by the model, you can see that attention was paid to a region which was outside of the tooth cementum. And on the next to it, you see a correctly predicted image. And here you see that whenever the image was correctly predicted, the model paid more attention to parts which belong to the tooth cementums. So we got more confident that actually the model could potentially learn from the tooth cementum.
So that meant that the next step is potentially removing anything which the model doesn't need to know. And we did that through a process called image segmentation. And this is the process which is currently used in self-driving cars, as you can see with this picture, where you have the car being able to designate as a car, that's a pedestrian, that's the road, that's not the road. And you could do the same thing with these images. So the process is it will find the labels, it will assign them properly, and then from that information, we can then remove what we don't need. Now there's a process behind this because the data sets that we had did not have these labels. So we had to create these ourselves, then train the model, and then compare the results on the full data sets. So I created these manually using a tool called CVATs, which there's a link online. I created about 240 images or so. And you can see already from just that and a quick run, the model is able to learn the labeling very quickly. And at some points, it was better than manually labeling the images, which was very impressive. And This is a result on a full data set where there's no mask, there's nothing for it to train against. It was just going pure blind, and it did a very good job for 91% of the images. As you can see, this is what we managed once we removed everything that was not tooth cementum. It's not perfect, as you can see in the third image, but that's just to show that no model is perfect. But for the vast majority of these cases, it did a very good job of getting rid of what was not necessary. Now, this is where we came to at the end of the 4 weeks. So the next step would be to try this again with slightly better images, which are more curated. Try the model again with these cementum-only images. And then once we have something that works, ideally we would create something which could be used by someone who is not necessarily familiar with how the machine learning works. So thank you very much, especially to the University of Freiburg for providing us the project, Albin and Badru at Propulsion for all of your help in the project, and just everyone at Propulsion for giving us what we needed to see this project through to the end. And we'll take questions.
You use teeth as your primary source, or is there anything else you could use to improve the recognition rate?
Alongside teeth, we used information around the tooth. So something called a tooth code, which is where the tooth is in relation to the body, the sex of the individual, the eruption, which is when the tooth appears in the mouth. But those were the only things that we included in this model training.
So for your customer, I mean, the University of Freiburg, what is the aim in the end? Is it why are they analyzing the age of people? You said it's for mostly archaeological studies?
It's a mixture of archaeology, anthropology, and forensics. It was specifically the Department of Biological Anthropology that provided this project. And the data set was based on teeth removed for orthodontical reasons. So sometimes there was damage to the teeth, which is why we had some issues. But yeah, the reason would be for that. Specifically, this process was used for a high-profile murder case in Germany some time ago. So the idea would be to improve the accuracy and the speed by which this could be used to determine the age of an individual.
So, but it's not for forensic applications, for example, or
it can be used for forensic applications. Yes.
Okay, thanks.